All right, for this next part of our unit, we're going to be talking about y equals mx plus b, which is actually what we call our slope-intercept form of an equation. So we're going to start off today on page 2 in your notes packet with the y equals mx plus b day 1. So starting off, we're going to kind of reactivate some prior knowledge that we had here. What does a proportional relationship look like on a graph? So when we saw proportional relationships, this is when we were talking about crazy k. So on a graph, if you remember, proportional relationships were going to be a straight line, and they were also going to go through the origin, which is the point 0, 0. So this was actually a linear relationship because it did form a line. So we were able to see that, and we had the straight line through 0, 0. For our equation for these, remember we had y equals kx, and this k we would actually replace, and we got a number. So we actually got k from doing k is equal to a y value divided by an x value before. So we were able to see, okay, we had a graph, it was a straight line, it went through the origin. We could actually write the equation in this format, y equals kx. And we got k from doing y divided by x. You'll probably notice that this equation is kind of similar, and it actually starts off similarly with this y equals mx part. This plus b is what we're going to explain in just a second here. So on the next part of your notes here, there's two separate graphs with two lines on each of them. So when I look at these two lines, I have the dashed line and the solid line. Which line, I'm going to ask you a question here, which line would you say is the proportional one, the dashed line or the solid line? So the solid line is our proportional one because it goes through 0, 0, and it is a straight line. So what we were able to do here is we could take this point, which is the point 1, 2. Remember, we always write the x coordinate first, and we could find our k value by doing 2 divided by 1, which gives us 2. So what we're able to know then is that for this particular line, our equation is y equals 2x. We could also, from our last little unit that we did on slope, we could pick these 2 points here and we could count the rise over the run. So we're going up 2 and to the right 1. So we could also say here that our slope of this line is 2 over 1 or just 2. So it's interesting here that our slope is actually the same exact thing as our k value. So these are going to be the same for proportional relationships. And this graph, just so that we can label it, is our proportional one. So let's go ahead, take a minute and do a little analyzing on this dashed line now. So I'm going to start here. It looks like I have 2 points. Since I don't go through the origin, I am not able to find a k value because non-proportional relationships do not have k values. For example, if I did y divided by x, I would get -2 here. But if I did y divided by x for this point, I would actually get 6. So since those k values are not the same, this one's not proportional, and I can see that because it doesn't go through the graph. So I'm going to instead go ahead and count my slope. So starting at the left, I'm going up 1, 2, 3, 4. And I'm going to run 1, 2 to the right, which is positive. So when I talk about the slope of my dashed line, my rise is 4, my run is 2. So my slope here is going to be 2. Notice it's the same slope as this solid black line here, and notice that they actually kind of look like they're moving in the same direction, and everything looks pretty much the same. The only thing that happened here that we need to talk to what happened to this graph, so as we go from the solid to the dashed line, it looks like instead of going through the origin, it now actually got shifted upward. So this gets shifted up, and this point now is going through where the y is 4. So this graph, what happened to it, it was actually shifted up 4 spots. So even though it's not a proportional relationship, the slope is still 2. So we're going to actually start our equation off with y equals 2x. But for now, we need to take into account that we actually shifted it upward. So because we shifted it up 4, up is a positive movement for spots. So because of that shift, we actually add 4 here. So our equation of this dashed line is y equals 2x plus 4. take a look over at this one. We have this dashed line that kind of looks like it's a little bit more solid. That's black. And then we have this dashed line that has a little bit of like a red overlay to it. Question for you here. Would the solid or the dashed with the red be your proportional line? So you're correct if you said that it was this solid one right here. This is our proportional one. Notice it goes through 0, 0, and notice it's a straight line here. What we can do is we can either count the slope or we can pick a point and find k. So we'll actually do both. We'll just pick this point right here because it looks like that's the best one. So this is the point 3, 4. So that tells me my k value would be 4/3. And using that, this point and this point up here, I'm going to rise 4 and I'm going to run 3. So the slope is going to be 4/3 as well. And remember, on a proportional relationship, the slope and the k value are going to match. So it looks like on this other line, instead of going through 0, 0, this red dashed line now got shifted downward. So we're going to make a note of that. What happened here? This was shifted down. And if we actually look at 0, 0, how many spots did it move down? 1, 2, 3, 4 is where it's crossing that y-axis. So shifted down 4 spots. If you remember from working with slope, if we went downward, that's going to be a negative movement. So this one, instead of being a positive 4, like this one was shifted up 4, this down 4 is actually going to be a -4 for us. So what we would do, since the slope of this red dashed line is the same, our equation is going to be y equals 4/3 x, and we're going to add that -4 because it now crosses the y-axis at that -4 spot. So these equations are actually using this y equals mx plus b format. So when we talk about y equals mx plus b, this is called slope intercept form. And your m right here is representative of your slope. You probably remember that from the last section. And this b value is representative of your y-intercept. So the y-intercept is where the line crosses the y-axis. Now, we can cross the y-axis if you go back up on your notes, up here at a +4, which would make that the b value be a positive, or we could cross it down here at a -4, which is what made this to be a -4 at the end here. We are not ever going to use double signs. So on that last example, if I'm writing this out using my formula, this is what I actually would have written, but we are not going to be using those double signs. So we're going to just write this as y equals 4/3 x minus 4. So this whole plus b part gets replaced with what your intercept is. So what we can do here is we can actually do a little bit of work with some things. If we know the slope, but we're trying to figure out the y-intercept, we can actually leave some things in as variables, and then we can actually replace the y and the x with values from an ordered pair that's actually on the graph of our line. So we'll look at that in a little bit later on, not this particular lesson, but that will kind of allow us to do some work if some things aren't very visible for us. So over on the next page here, we're going to actually write the equation of some lines. So we're going to be kind of doing a 3-step process here. So we're going to have y equals blank x, and then I'm going to put a blank. And off to the side, we're going to be identifying m, and we're going to be identifying b. So I'm going to do the same setup for this second one right here. Y equals blank x, blank, and then I'm going to have m equals and b equals. So let's go up to this first one on the left side. We're looking for the slope and the y-intercept. The slope is actually labeled on here. It looks like it tells me that I'm going 1 to the right, which is a positive, and then I'm going down 4. So rise would be the -4, the run would be the +1. So that's going to be a -4 slope for us. So that's a -4. And the next thing we need to do is identify the y-intercept. So we're going to go ahead to the y-axis here. And we're going to look along that y-axis and determine where does the graph of the line actually cross over the axis. So if you're looking up and down the axis, it happens right here. And this point is a positive 7. So my y-intercept, while we can write this out as the point 0, 7, we just need the y coordinate of that. So my y-intercept is 7. If I go back to my equation, which is y equals mx plus b, I'm going to plug in a negative 4 attached to my x, representing my slope, and then my y-intercept is a positive 7, so I'm going to put plus 7. So the equation for the graph of this line is y equals negative 4x plus 7. And this next one, we're going to do the same thing. I've always drawn the slope triangles on the bottom. You can draw them on the top here. It doesn't really matter. Either way, if you want to draw them the way that we have been doing, we are going to be traveling down 7, and then we're going to be traveling to the right 6. So that slope is going to be negative 7, 6. And again, we're just going to push that negative out towards the front. We don't have to keep it up with the 7. And then go back and look at my y-intercept. So if I look at my y-axis, which is going right down here, where does my line actually cross over the y-axis? It happens right here. And this is where y is negative 1. So my y-intercept is negative 1. For the equation of my line then, y equals negative 7, 6x minus 1. Again, double check your paper right now. You should only have one single symbol in here. It should not be plus and a minus. It should just be a minus then. Down at the bottom of this page, there are 2 more examples down here. Noticing these 2 do not have the points anymore, so we're going to actually have to pick some points. I'm going to actually do this strategically and go down my y-axis and then put a dot right here. So I've actually just identified that my y-intercept is a positive 2. I also need to identify what my slope is. So I notice there's a point here, and I also notice it goes through right here. So I'm going to go from this point down 2 for my rise and to the right 2 for my run. So negative 2 over 2, which is going to give me a slope of negative 1. So for the setup of my equation, y equals blank x blank. So my slope was negative 1, so that's going to be attached to the x, and my y-intercept was a positive 2, so I'm going to put a plus 2. So my final equation, y equals negative 1x plus 2. If you remember from math class, this 1 is actually kind of an invisible number. So another acceptable way of writing this, and this is how they'll want to see it in 8th grade Algebra 1, is just to write this as negative x plus 2. In the next example, again, I'm going to be strategic, go down my y-axis until I get to the line, and here's my y-intercept. So I'm just finding my slope and my y-intercept. My y-intercept is negative 1. I need to identify another point on my line, so it looks like there's one right here. So my rise is 1, 2, 3. Run is 1, 2, 3, 4, 5. So it looks like my slope is rise over run, 3/5. So my equation is y equals 3/5 x minus 1. That minus 1 tells me that this line gets shifted down 1 spot. On the next page, we have a couple more examples here. So starting off with this first one up at the top, I am actually going to, oops, it looks like I missed a set of examples here for you. All right, well, we're going to actually do this then as ones that you can do. So if you are on the very top of this next page here, which for you is going to be page number 4 in your notes packet, we're going to look, there's 2 graphs up across the top. So we're going to look on this left side. I'm going to ask you to identify the slope, the y-intercept, and then to also write out what your equation is going to be. And then on the right side, I'm going to ask you to do the same thing. Slope, y-intercept, and what's your equation going to be? So the first thing I'm going to ask you is to go ahead and to enter in what is your slope. So for this one, I picked 2 points. I found that my rise was a -3, my run was a 1, which gives me an overall slope of -3. What was your y-intercept? The graph crossed over the y-axis where y was a -3, so that's going to be my y-intercept. Take a minute, type out what is your equation. So using your slope-intercept form, you're going to have y equals -3x minus 3 then. Go ahead, take a look on the right-hand side, and I'm going to ask you on this one, what is the slope of your line? My rise was 3, my run was 1 for the points that I used, giving me an overall slope of 3. What is your y-intercept? The line actually crossed over the coordinate graph where y was -2. So my y-intercept is -2. Take a minute and type out your equation. So for this equation, we should have y equals 3x minus 2. So down also on page number 4, there's 3 more examples here. There's this one right here. I'm going to ask you to go ahead. What is your slope? So I use this point right here as well as this point right here. So it's a 1, 2, 3 down, 2 to the right. So my slope is going to be -3 halves. What is your y-intercept? The y-intercept happens up here where y is 4. And the final step, type out what would your equation be. So using the slope as mx plus your b value, your final equation is y equals -3 halves x plus 4. So what about lines that look like this, horizontal and vertical lines? So in this particular one, if you remember from Mr. Slope Guy, so we have plus, minus, and we have undefined for the nose, and then we have 0 for this. The slope of this line is going to be 0. So slope is 0, that's m. B we can identify because it does go through the y-axis, so b is 3. So if we were to write this out, we're going to have y equals 0x plus 3. So 0x we don't even have to write because it's nothing, so we're just going to have y equals a positive 3. So horizontal lines going side to side are going to be y equals equations. And that makes sense because it goes through the y-axis. For this one over here, our slope is going to be undefined. So thinking about Mr. Slope Guy, that's that vertical line. There is rise, but there's no run. So we don't have a 0 in the denominator. There is also on this one no b value because this does not go through the y-axis. So our equation y equals mx plus b is not going to work on this sort of line. This line, if you notice, goes through the x-axis. Keeping in mind this one went through the y-axis and our equation was just a y equals the number, this one's going to follow the same pattern. So since it goes through the x-axis, it goes through at 5, so the equation of this line is just x equals 5. So all you have to do with horizontal and vertical lines is take a look at which axis does it go through, and that will identify what your equation is going to be for you.